Before proceeding into the solution, we need to understand one method which we use to convert the initial value problem to a Volterra integral equation just to perform the Laplace transformation. So, as a given question, we need to perform the Laplace transformation on the given equation. So, before proceeding into that, let me explain the method. So, whenever you see integration 0 to x, dot 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 integration 0 to x yt dt dt dot 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 dt. So, this will be n time and this will be also n times. Whenever you see this type of format, you have to convert this into integration 0 to x minus t to the power n minus 1 by n minus 1 factorial yt dt. So whenever you see this format, you have to perform this way. The given question, it is asked to find the Laplace transformation of y double dash minus 2y dash minus 3y is equal to 0, where y0 is equal to 4 and y dash of 0 is 0. Now we have to find this way. So let's see. So we'll take this equation y dash minus 2y dash minus 3y is equal to 0. Let me explain one thing here, that is, when you write double dash, it means d square y by dx square. So now we'll integrate both sides with a limit of 0 to x. So we'll integrate all of this. So this will be double dash t dt. When we integrate, we have to convert the variable into t minus 2, as 2 is a constant, so it will come out. So integration of 0 to x, it will be y dash t dt minus 3 integration of 0 to x yt of dt is equal to 0. Integration of 0 will be 0. So that's how we'll convert this into a Volterra integral equation to find out the Laplace transformation. So after that, this will be, to perform this thing, we know how you can write this. This will be y dash t and the limit will be 0 to x. This will be 2 and the integration of this thing will be yt and the limit will be 0 to x minus 3. As we do not know the yt, so we cannot integrate this part, so we'll keep it this way, is equal to 0. After that, we'll put x here and the 0, so this will be y dash x minus y dash 0. This will be 2 y of x minus y of 0, and this will remain the same. Now we know the values of y dash 0 is 0 and y0 is 4. So we'll put these values here. So y dash 0 is 0 and y0 is 4. So this will be y dash x minus 0 minus 2 yx minus 4 minus, this will remain the same, 0. So Now we'll simplify this thing. Now we simplify this equation like this way. It will be 0 and minus 2 yx. This will be minus plus 8 minus 3. This will remain the same, and this will be y dash x minus 2 yx minus 3 integration of 0 to x yt dt is equal to minus 8. So now we have to integrate both sides again. So when we integrate both sides, we'll have integration of 0 to x. When we integrate this part, this will convert into a variable. So this will be y dash t dt, right? This will be converted like this way. And this will be 2 as a constant will came out, 0 to x, and this will yt dt minus 3. This will integrate once again 0 to x and again 0 to x. Yt dt is equal to minus of 0 to x 8 dt. So we have from here, this will be integrated. When we integrate this part, this will come out like the previously. So this will be yx minus y0, right? When we integrate and put the limits in it, it will come out this one minus this one yt. You do not know the yt, so we cannot perform the integration here. So this will remain the same, yt dt. And as I mentioned earlier, this way, when you see the format like this way, we have to perform the method where I have shown you the method, this one. This way we will perform the method. So let's perform the method here. So when you perform the method here, it will be, this is 2 times, so 3 will be here, and when you perform it, it will came out integration of 0 to x minus t, and as a n it will be 2, so 2 minus 1 will be 1, so you do not need to write it here as 1, and the below in the denominator will be n minus 1, where n is 2, so 2 minus 1 will be 1, so you do not need to write this way. Okay, so we'll put this x minus t here, and this will be yt dt equal to, this will come out when the constant will come out minus 8, and the integration of t, that will be x, and when we perform the limit here, it will give us minus, this will not x, this will be t. After performing the limit, we'll have 8x and minus of 0, which is 0. We do not need to write it. So now here we know the value, which is 4, right? So this will be yx minus 4 minus 2, 0 to x yt dt minus 3 integration of 0 to x. This will be x minus t yt dt is equal to minus 8x. Okay, so after that we'll write it as, this 4 will came here, so yx minus 2 integration of 0 to x yt dt minus 3 integration of 0 to x minus t yt dt equal to 4 minus 8x. We have the Volterra integral equation. Now to perform the Laplace transformation, we need to know one concept, which is, if a inverse is a Laplace inverse of ys ks is equal to integrate integration of 0 to x yt x minus t dt. So we can write it Laplace of integration of 0 to x yt k x minus t dt is equal to ys star ks. So I can write this thing. Okay, so this is a method. Now to perform this task we need to write this thing uniquely. So let's write it as this way: yx minus 2 integration of 0 to x. This will, we can write it as yt x minus t to the power 0. As something to the power 0 is 1, so we can write it as this way. So it will remain the same here. So dt and 3 integration of 0 to x, let's write it first this one, and this will be x minus t dt equal to 4 minus 8x. Okay, so now we can write this thing here. It will be yx minus, this can be written as the given method. We can use the method and write it as yt star, this will come out x to the power 0. Okay, minus this will be 3 and this will be yt star, this will come out x to the power 1. So as you can see, the power is 1, power is 0, so x to the power 0, and this power is 1, so this will be x to the power 1. Okay, now the remaining part, this is 4 minus 8x. After that we will have to take the Laplace both side. So Laplace of yx minus 2 will came out here, Laplace of this thing. So Laplace of yt star x0 minus 3 Laplace of yt star x to the power 1 is equal to Laplace of 4 minus 8x. So Laplace of this can be written as y bar, the simply short way to write it. So Laplace of x will be this. So a little correction here, it will be x, this is t, and this will be x, as well as this will be x. Okay, when we put x, we'll have this one x. Okay, so this will be x. So after that we'll have from here y bar. We can write Laplace of yx is y bar minus this will came out. We have to perform the Laplace transformation individually for both this. Okay, the Laplace of yx will be simply y bar, so we'll write it as 2 y bar into, we have to perform this separately on x to the power 0. So x to the power 0 is 1, and Laplace of 1, Laplace of 1 is 1 by s. Okay, Laplace of x is equal to 1 by s square. So we need to keep this in our mind. Okay, Laplace of yx will be y bar, and Laplace of x to the power 0 will be 1 by s minus 3 Laplace of x yx will be y bar, and Laplace of x will be 1 by s square, equal to Laplace of 4 can be written as 4 into Laplace of 1. So Laplace of 1 will be 1 by s, so Laplace of 4 will be 4 by s, minus Laplace of 8x will be 8 by simply s square. Okay. So let's simplify this. Y bar will come out as a common. This will be 1 minus 2 by s minus 3 by s square, and this will be, when we take a LCM here, it will be a square and 4s minus 8. And this, when we take this one as LCM, this will give s square minus 2s minus 3 is equal to 4s minus 8 by s square. So after that, when we cross multiply it, we'll have 4s minus 8 by, this will, when we cross multiply it, it will give s square minus 2s minus 3. Okay. So now here, that is the partial fraction. The partial fraction of this is, so the partial fraction of this will be 3 by s plus 1 plus 1 by s minus 3. Okay. So we'll have the partial fraction here. So we'll put this here. So y bar equal to, or y bar, we can write this y bar as Laplace of y. Okay, Laplace of y or y of x, we can write it as this way. So this will be the fraction part. This is 3 by s plus 1 plus 1 by s minus 3. Okay. So now the Laplace of, we'll take this Laplace here, so it will create the inverse Laplace transform. So y is equal to Laplace of inverse 1, that is 3 by s plus 1 plus 1 by s minus 3, which will give us, we know, when is a Laplace inverse of 1 by s minus a is equal to e to the power at. So according to this formula, we can write this thing as, we'll perform this one as a inverse Laplace and again this one. So this will be Laplace of inverse 3 by s plus 1 plus Laplace inverse of 1 by s minus 3. From here we'll have 3 will as a constant came out, and 1 by s plus 1. There is plus, so it will come out e to the power minus as 1, so it will 1 and t plus Laplace inverse of 1 by this is a, so this will come out e to the power, as this is minus as the formula, so it will come out as positive, so it will be 3t. So we'll have y is equal to 3 e to the power minus t plus e to the power 3t. So the required answer will be this one.